Hi everyone. Let's discuss the solutions to the second contest today. So the first question was sales. So if you try to analyze the question in detail, what you will realize that this question is nothing but the famous birthday paradox question, which I have just written in a modified set of sentences, just so that you cannot recognize it directly. Yeah, so in order to solve this question, what you really have to do is, if you see the question is Q is the probability that at least two sales happened on the same day. So we are given information about sale from 1 year, which is not a leap year, which means it has 365 days. Now, if Q is the probability that at least two sales happened on that day, that means what we need to find is what is the minimum n so that we can be sure that Q is greater than P. P is the probability that P is the probability which is given in the input. So you have T test cases in which you get a P probability, and you have to find minimum n such that what happens is Q, the probability that at least uh, two sales happened on the same day. So let's see the sample first. So in the sample we have P is equal to 0. If probability is 0, we need at least two sales. So n is 2. Like if you have n equal to 1 sale, there is no chance that you can have at least two sales on the same day. So if we have n is equal to 2, we get that the probability that at least two sales can happen on the same day is non-zero, like probability is greater than 0. Then for 23 we will have to calculate, so we cannot say directly. The solution to this would be the solution to the standard birthday paradox problem. So what happens is, if for n equal to 1, the probability that all birthdays are on distinct days is 365 by 365, because there is just one person. If you have two persons, what happens is the probability that all people have distinct birthdays or distinct sales days in this case is 365 by 365 into 364 by 365, which is equal to 364 by 365. Because what happens is, if person 1 and person 2 don't have same birthday, so you can fix person 1 as any of the 365 days, and for the person 2 you have 364 options. So what happens is, you can have 364 options for the second person, and out of the 365 possible options, if uh, you get a probability of 364 by 365 for which the person 1 and person 2 don't share a birthday. So if you want to find the probability that they share a birthday, you have to do 1 minus this. So answer will be 1 by 365. So if you have two persons, the probability that they share the birthday or sales day in this case is 1 by 365. So similarly, if you have n, what you need to do is the probability will be 365 by 365 times 364 by 365 times 363 by 365, and so on and so forth. So in numerator you decrease by 1, and the denominator remains uh, same. It remains 365, because there are, for each sales, there are 365 possible options, and out of them you can get any one at random. So what happens is, you can look up the birthday paradox, and the answer becomes that if you have n sales, the probability that all of them have distinct days, it will be 365 by 365 times 364 by 365 times 363 by 365, to so on up to 366 minus n upon 365, and you have to do 1 minus this probability, and if that is your Q. So then you try for all n equal to 2 up to 365, and whenever you get that 1 minus this probability is greater than the P that is given in the test case, you print that. And for 0.5, you will find that up to n equal to 22, this probability is less than 0.5, and whenever you get 23 people in the room or 23 sales, the probability that at least two sales happen on the same day is at least 0.5. So you can get it by calculation. And then that's why the question was marked as easy, but I don't know why like many people did not attempt that question. So I think if you would have tried reading like standard topics from probability like birthday paradox, you could have found that this question is just birthday paradox modified. Now let's move to the second question. This question is a bit involved. So Again, like in the previous videos, we talked about the time complexity estimation and such things. So this question involves those. So because because the full solution is quite complicated, I have put several test cases in which partial solutions can pass. So I think many of you tried, but one problem was that many of you are trying with Python, and Python is a bit slow. So like as previously, I recommend using C++. And also many of you did not know the optimal solution, so let's discuss the optimal solution, what happens. And so first, let's discuss the solution for 50% points. So the question is, you are given n, the name is primordial, but some of you might have got confused, like this question is not exactly about primordial. Primordial means something else, but I've just modified the question slightly so that it becomes something new, so that you have to think. So in this question, what you have to do is, you are given n, and you have to find the product of all primes less than n, and then you have to find the last k digits of the product, which are rightmost digits. So by rightmost digits, we simply mean that modulo 10 to the power k. So if you have a product which is the product is x, and if you take 10 to the modulo 10 to the power 5, you will get last k digits, which will be y. So this is the y that we need to find. Now we are given a condition that you have to use only 32-bit and 64-bit integers. The point of that was that if you try to use big integer libraries and such things, the question can be solved trivially, because like in so if you try to find the product of primes, all primes up to 10 to the power 5, it will be some I don't know, 100-digit number or something, and or maybe too long number. So if you can store that in a big integer library, the purpose of this question is directly like neutral. So there's no point of this question. So the question, what I expected was, like, you have to find this product using only 64-bit integers, and it's not possible to solve it using 32-bit. So for I think for first three test cases, I up to 50% points you can get by using just ints, but it's just recommended to use 64-bit integers, which is like long in Java or long in C++. So how to solve this question? So let's move to that. So first of all, there is a algorithm called its name is Sieve of Eratosthenes. And in the Sieve of Eratosthenes algorithm, what happens is, you have to find the algorithm is to find all primes from 1 to n. So using that algorithm, you can find all the primes. So algorithm works like this. Uh, for I equal to 2 to n, for j equal to all multiples of I. So how do you iterate on all multiples of I? J goes from 2 times I to n, and always you do j plus equal to I. So j always jumps by I. So j will go like 2i, 3i, 4i, up to so on, up to whenever it reaches n, it will stop. So I goes from 2 to n, and what you do is, you initially make an array of size n. You set it as all ones, which meaning all numbers are primes. So you make an array is prime, you set all of them as 1, which means all numbers are prime initially. We by default assume all of them are prime. Then we iterate from I equal to 2 to n, and j is equal to 2 times I to n, and j goes like this. So j jumps by I. So 2i, 3i, 4i, 5i, and so on. So j jumps on all the multiples of I, and you mark is prime of j as false, because like a divisor of j is I. So because of that, we know that j is not prime. So if you do that, you can find using this algorithm, you can find all primes from 1 to n in time complexity big of n log n, for which you can see Wikipedia article or Geeks for Geeks. And using that, so if you can find all the primes in n log n, what happens is, you can easily, so now the multiplication part, so that's another interesting part. So then you iterate on this array, and whenever you see that is prime of I is 1, which means this number is a prime, what we do is, we keep a running variable called answer or multiplication, or we can call it x, because it is defined as x in this question. So what you do is, you set x equal to 1 initially. Then whenever is prime of I, so if I is a prime, what you do is x equal to x times I modulo a mod. The mod is 10 to the power k. So first you compute 10 to the power k, which for which you do not need to use anything like pow function from math library or anything. You can just do normal multiplication because it just takes k loops to find it. So big O of k, you can find the product in big O of k, and k is pretty small, so like you don't need to do anything else. And then you can find mod equal to 10 to the power k. Then what you need to do is answer equal to answer times x modulo mod. And then after you find that product, by doing this modulo thing, this is called modular arithmetic, and it was one of the another topic that I had put in the resources. So what happens is when you do this modulo along with multiplication, at each step you can ensure that this does not exceed your mod, which means it will fit into a long, which was the purpose of the question. So like if you multiply all primes first and then do a modulo, that's not exactly like, that was not the purpose of the question. That goes against the purpose of the question. And then what happens is you find this multiplication using this solution, you can pass 50% of the test cases. So for 50% of test cases, what happens is t is up to 100 and n is up to 10 to the power 5. So what happens is for each test case you get nnk. You find all primes in 1 to n using the n log n algorithm that I told, Sieve of Eratosthenes. And you find all the primes, and then you find their multiplication and modulo, and that's the answer. So the total complexity becomes big O of n log n into t, which is just enough to pass the 50% test cases. So it will be like roughly 100 into 10 to the power 5, and I have tested that it passes using C++. So yeah, I think that solution will pass, which is 10 to the power 7. Now let's move to 100% solution. So like, what is the perfect optimal solution uh, for this question? So how to solve this question optimally? So if you try to analyze this question in detail, what you will find is that all the test cases are not independent, so they are very overlapping. So one other thing is that let's say if you, for let's say you have one test case in which you have n is equal to 10 to the power 6, as we can see in the last test case. So you can go at t up to 10 to the power 5 and n is up to 10 to the power 6, which means the solution that we expect, so anything like O of nt will not pass. Like previous one was t times n log n, which passed for the 50% test case. But for 100% score, what you need to do is something less than big O of tn. So it can be something like big O of t plus n log n, which is what is in this case, or it can be something like big O of t plus n, or anything like that. So basically t and n should not come in multiplication, because otherwise 10 to the power 5 times 10 to the power 6 is something too large to pass in 1 second, which is as again we can remember 10 to the power 8 operations per second. So what happens is if you try to find the redundancies in this question is called now the solution that we are going to discuss is called query optimization using pre-computation, or memoization as it is called. So how does pre-computation help in this case? So if you have a test case in which n is 10 to the power 6 and you can find all the primes from 1 to 10 to the power 6, you don't need to compute it again and again for all n. For let's say if you get n again, for first test case you get n is equal to n to the power 6, and then for the second test case you get n is equal to 1000, so you don't need to compute it again for n is equal to 1000. So how do we do this? So what happens is before starting any test cases, you try you run this Sieve of Eratosthenes for 10 n is equal to 10 to the power 6 plus 1 or something. So you run it for 10 to the power 6. So you find all the primes from 1 to 10 to the power 6, and what happens is you find primes. Now how about product? So you just found the primes. Now you keep an array called product, which will store prefix products. So prefix product is like product from product of prime from 1 to n, like where n is some, like let's say, so so product of 2 will store the product of primes less than equal to 2. Then a product of I will store product of primes from 1 to I, and so on. So how do you do this? So you might have heard about prefix sums. So this is similar to that. This is in prefix products. So in prefix products, what you do is if you set prod of I is equal to prod of I minus 1, and then if I is prime, what you do is prod of I is equal to prod of I times I modulo mod. So because of that, you can store product of primes from 1 to I in the broad array, and you store it modulo mod. Now what mod to take? So because the question here has a nice property, then you need to find the last k digits, and k goes up to 12. So what happens is, if you just keep the products of primes modulo 10 to the power 12, what happens is, if you have last 12 digits, and from if you have a last 12 digits of a number and you want to find last 5 digits, so what you just need to do is take the last 5 digits from the 12 digits. So that's the result modulo 10 to the power 5. And if you do that, what happens is, you just have last 5 digits, so that's your purpose is solved. So first you so this is the answer finally. So what you need to do is, you just find the primes from 1 to 10 to the power 5, so 10 to the power 6, whatever are the constraints, and then you find the prefix product I. Prod of I is equal to prod of I minus 1 times I modulo mod. If I is a prime, you multiply I. If I is not a prime, you just copy from the previous one, because like let's say if 6 is not a prime, right? So what happens is, prod of 6 will be equal to prod of 5, but 7 is a prime, so what happens is, prod of 7 is equal to basically it's like a recurrence, right? So in recurrence, what you need to do is, if I is a prime, prod of I is equal to prod of I minus 1 times I modulo mod. And if I is not a prime, what you do is, prod of I is equal to prod of I minus 1. and and then again, what will be the mod? Mod will be 10 to the power 12, because that is the maximum modulo that you need to store. After, like, beyond 12 digits, you don't need to store anything. So now how do we run the test cases? So you take t, which are the test cases, and take n and k, and then you find 10 to the power k, which is the modulo, store it in some variable, like call it mod, small mod, like different from the original mod, and then you just take y is equal to prod of n modulo mod. You take the product which are already stored of primes from 1 to n, and then you take it modulo mod. So you will get the answer modulo 10 to the power 5 k, which is exactly what you want. So that's how to solve this question. Now, what was so special about this question? So I think many of you were able to find the 50% solution. So that's because, like, if you know Sieve of Eratosthenes algorithm, you can easily find the 50% solution, which is essentially, for each test case, you just run Sieve of Eratosthenes, find primes from 1 to n, and then take the product modulo k, 10 to the power k. So that's the answer. But for the second part, the main solution was how to remove the redundancy, how to stuff so that you don't have to compute primes from 1 to n again and again and so on. So how to do that? The main idea is called pre-computation. So what we did was pre-computation. Before running any of the test cases, what we did was, since we know that n cannot be about 10 to the power 6, we can just pre-compute all the primes from 10 to the 1 to 10 to the power 6, and then use it for all the test cases, which saves us big O of n time for each test case. So what, for each test case, just becomes big O of 1, because you just go to prod, you have already computed product of 1 to n, and then you take that modulo 10 to the power k, and you just have your answer. So that's a really great way to optimize things. So it will come handy, like many of the questions that you may see in future. Now let's move to the last question, which is hard question, diversity and inclusion. So if you have gone through the resources, you will know that this is basically an advanced binary search question. And if you solve the question aggressive cows, like this is very similar to that, just a variation that I came up with myself. So what happens is, first we know that divide and like how divide and conquer algorithms work. Now how to do binary search. So we know binary search on arrays, right? But another important thing is, we can do binary search on functions. So if a function is monotonic, it either it only increases or remains constant. So like if the function is like y is equal to e to the power x, it always increases, right? So if you have some function which always increases or remains constant, you can apply binary search on it to find some value, like based on your threshold. Like if you have a function like y is equal to e to the power x, and you go to find minimum x such that y is greater than or equal to 2. So what you need to solve is e to the power x greater than or equal to 2. So x will be ln2. But let's say you cannot compute ln using your library. So how do you do it? But you have a function for e to the power x. You don't have a function for ln2. How do you do that? So To find inverses, this can be used. So how to solve it? So what happens is, if you have a function which gives you an e to the power x, and you want to find how like what is the minimum x such that y becomes greater than or equal to 2, what you do is you binary search on x from 0 to 10 to the power 18 or whatever you think might be the range for the answer. It depends on you, like based on your observation you can say that ln2 will be something between 0 to 10 or something 0 to 100 and so on, or it can be negative, I don't know. So in this case actually ln2 will be log e will be 0 and ln2 is negative, so you have to binary search between -10 to 10, and you take an x, like you set low is equal to -10, you set high is equal to +10, and what you do is you find mid, you check what is y for mid, so you find e to the power x. Let's say your mid is 0, so what happens is e to the power 0 is 1, and now you want to find like whether, so answer is 1, what you wanted to was 2, so is answer less than what you wanted to find or not? So if so 1 is less than 2, so because of that y is an increasing function, we know. So if 1 is less than 2, we need to increase x, so you move in that direction and so on. So that's the idea behind binary search, and if you implement it, you can find inverse functions like that. So now let's move to this question. Now this question says that you have an array, so let's first understand what they mean by subset. You have an array, and subset means like if you have an n element array, you can find any of the 2 to the power n subsets as defined in like maths. In maths you might have studied sets, so it's similar to that. So subset means you can have either 0 elements from the array into it, or 1 element, or 2 element, 3 element, and so on, like in any order. And in the set or subset, order does not matter, so you can have 2 to the power n subsets of a set, and you essentially in this question you have to take an array as a set. So like if you are unclear about the subset thing, you can just look up the definitions, and it's like quite easy. Now let's see about what else is in this question. So if you have a subset, diversity of subset is defined as max of mod of ai minus aj. So if you have a subset like let's say 4 2 3 5 7, the diversity will be the maximum difference between pairwise elements in the subset. So you don't actually need to find the pairwise difference. So like if you try it on 2 3 examples, you can see that if you have the subset 4 to 537, like the maximum diversity in this will be difference between max and min. So for let's say set 4 to 537, diversity will be max is 7, min is 2, so diversity will be 5. So that's one of the things that you need to prove. So that's proof based thing, and if you can come up with that, the question becomes very easy. So for a subset, diversity is just the difference between max and min. That's one of the things. I think one of you did come up with iter tools based solution in which you iterate over all the subsets of array and try to solve it. So that's a good thing. Like if you know Python tools well, it's Python libraries well, it's a good thing, and you can pass some partial test cases based on that. But the actual solution expected you to not use that, because like when you see n is up to 10 to the power 6 for the last test case, or even the third one, when you have n is up to 1000, you cannot afford to do 2 to the power n all subsets, like that will not pass. So you need to do something smart. So now what happens is you need to iterate over all the subsets of size k, exactly k, so nothing like greater than k or less than k. You have to iterate on all the subsets of size k, and diversity is difference between max and min. Now what happens is in this subset, you have to find minimum k such that every subset will have at least d diversity. Now based on maths, we know that like a subset can have size between 0 to n, like both are possible, because you can have an empty subset which will have size 0, and you can have like whole arrays subset which will be size n. So k can be between 0 to n. So for k you need to do a binary search between 0 to n. But how do we do that binary search? So you for k you do a binary search between 0 to n. If you are given okay, so like let's say your low is equal to 0 and high is equal to n, and now you take a value which is mid is equal to low plus high by 2. Now we want to find the diversity in this subset. How do we solve it? K does not have to be a factor of n, so that's one of the things, so that people don't get confused. Like, yeah, you don't have to partition the set, you have to iterate on all the subsets. So uh, yeah, now what happens is, if you're let's say you have this subset 48251, which is given in the example, you can have diversity of 1 minus 8, which is 7, max minus min, so that's the diversity, which is 7. And how do we solve this question? So for k, you need to binary search between 1 to 0 to n. And when you have a k, when you have a size k of some size, what you do is, you want to uh, find the subset of size k which has minimum diversity. So in your array, if you have all subsets which have like, if the subset with minimum diversity has diversity greater than or equal to d, based on that we can conclude that all subsets have diversity greater than or equal to d. How do we do that? So if we sort the array, what happens is, we can, the contiguous k elements, so if you sort the array and you take first k elements, they will be the closest to each other possible. Like and same for second element. So like if you take second to k plus 1th element, they will be closest to each other as possible. Then if you take third to k plus 2th element, and so on. So what you do is, you sort the array, you take all k contiguous elements, so like 1 to k or 0 to k, then 1 to k plus 1, 2 to k plus 2, and so on and so forth. You can find the all the k size subsets which have minimum diversity. Now for each of them you check whether diversity is greater than or equal to d. So for each of the contiguous subarrays, now it reduces to subarray. Now let's understand what is a subarray. So subarray is a contiguous subsequence, like subarray is a contiguous part of an array. So like if you have an array and if you take some sequence of arr I to j, so if you take from any index I to you go to any index j, you get a subarray. So now from subset we have reduced the problems to a subarray, so by sorting. So now you iterate on all the subarrays of size k, and what you do is you find the diversity, like the max element minus min element, and you don't need to search the max element either. So like arr of I plus k will be the max element, and arr of I will be the minimum element for subarray from I to I plus k. And you take the difference, so arr of I plus k minus arr of I, and that will be the diversity. And now what you need to do is, if this is greater than or equal to d, then we know that diversity is greater than or equal to d for this subset. Now so for this subarray, sorry, so you do this for all subarrays, and for each of the subarrays, if diversity is greater than or equal to d, what you have is, this k satisfies the given property. Now we want to find minimum k which satisfies the property. Why? Because like if you directly take like k is equal to n, you can always satisfy the property, right? Like if you large enough array, and it will always have the required difference, like more likely than smaller n k by, I mean, like if you take k is equal to n by 2, and if you take k is equal to n, we can be sure that k is equal to n will have more diversity than k equal to n by 2. So based on that, we want to find minimum k which satisfies this. So if all the subarrays satisfy this property, what you do is, you set high is equal to k. So if you are binary searching from low to high, now you binary search from low to k, because we know that this k satisfies the property. And if this case does not satisfy the property, you will binary search from k to high. High you set low is equal to k. So based on that, you can binary search in one of the two directions, and you can find the minimum k which satisfies this property. And uh, if you can find the minimum k which satisfies this, uh, another thing that you need to consider is array elements and diversity is up to 10 to the power 18. So you need to use 64-bit integers like long in C++. And if you try to use 32-bit integers, it will give a wrong answer because it will not be able to fit. So yeah, that's one of the other things. And other than that, let me check if there is anything else in the solution. Yeah, so you need to sort the array, and you need to binary search from 0 to n for k, and you need to find the minimum k such that ARR of I plus k minus 1 minus ARR of I is greater than or equal to t. And if you find that, you can always see that like if the current k satisfies the property, you binary search on the left part I low to k so that you can reduce k. If current k does not satisfy, you binary search from k to high. So that was all about this. And I think the performance of this test was a bit down. So in order to improve it, basically if you would have solved the first for the first question, you just needed to know basic probability and stuff. So like uh, there is a problem called uh, I think it is some goat related problem, goat and three gates problem. I don't remember its exactly name. And then there is this another problem which is called birthday paradox, and there are many such standard probability things which you need to know. Like if you know probability and statistics and this permutation combination, you can solve the first question. For the second question, you need to do this Sieve of Eratosthenes, which many of you did not know already, and many of you are just copying the Sieve of Eratosthenes code from Geeks for Geeks. So like that's not okay. Like normally when you have a company coding test or interview, you will not have access to internet. So please try to learn Sieve of Eratosthenes on your own. Please learn what is modular arithmetic, what are different basic number theory topics which I had posted resources of, and please solve questions based on them. Like if you know like different topics in number theory, and if you have solved a few questions, like you could easily solve the first two questions at least. And third question, I agree, it was a bit hard, that's why I had put it with the hard tag. And for the third question, what you needed to know was advanced binary search, and if you solve a few questions like aggressive cows and the Medium article that I had posted, like then you can easily tackle such questions. And many product based companies like often ask such binary search based advanced questions which are basically application of binary search. And if you can solve the third question, basically you can crack almost any company's interview in India for at least freshers, because that's the hardest it can get in DSA. And yeah, with that, like best of luck for this week's resources and questions as well. Please try to go through the resources of this week as well as first 2 weeks, and please post the doubts on the group. I think the group is very inactive. Like from your end, like there is not a lot of activity, only the mentors and like Himadri are posting a lot of things. And like please make the group active. Yeah, okay, bye.